So thank you very much. We're really happy to be here. I mean, it's our first time here. I'm in Geneva and also part of this conference. So thank you very much for the people that made this possible for us also to come all the way here. Today we're going to be talking about threat hunting research, a data-driven approach, and we're going to share a little bit of a couple of things that we've been doing and also releasing an open source project today as well, and tell you how a lot of things that we do can be put together and can also be even replicated at home or in your own organization as well. Once again, my name is Roberto Rodriguez. You can follow me in Twitter. That's my handle. And I also have a couple of GitHub projects. The link is at the bottom. So if you have any questions, please, I love to talk about all these projects. So if you want to probably, get interested in something, please just let me know. And I'm also a detection researcher for a company in the United States, based in Seattle, which is SpecterOps. And also, I'm a former threat hunter for Capital One, a financial industry. I'm also in Virginia.
Hi, everyone. My name is Jose Luis. I go by CyberPanda in Twitter. I'm a cybersecurity student at Northern Virginia Community College in the U.S. As Roberto told you, we are releasing today our last project, Mordor. And I also like to contribute to open source projects that we are working with Roberto. And I'm a former senior business intelligence analyst from UNACEM, Peru.
Yes, so we're both from Peru, actually, but we reside in the United States. So just in case you guys probably might wondering. All right, so why are we here? Today we're going to be talking about first into what we've seen and what I've seen also traveling around different companies, trying to apply threat hunting methodologies and frameworks and things like that, all the way to start talking about a data-driven methodology and why we even care about data in this aspect. And also we're going to be applying a couple demos and things like that. And of course, releasing one of our projects at the end. So currently threat hunting, before we even talk about that, I think it's important to understand exactly the differences between being effective, efficient. There is a lot of people that use these concepts in a different way, which makes it really hard to understand how you're actually being effective. And the reason why we want to do this is because these concepts will be applied across our, methodology, right? Because we want to make sure that whatever we do with our data is being done in the most efficient way so we can achieve also our effectiveness. Efficiency here comes from how can you make the best out of the resources that you have and in a let's call it like an optimal way. And efficacy is pretty much when you are setting yourself a goal and you achieve that goal no matter what. Right? So the combination of these two is supposed to be part of the effectiveness, concept. So this translates into cybersecurity, kind of like getting into the topic. Being efficient is not just having, tools or having people. It's actually having the right people, the right data, and the right tools. And then that will help you, of course, to achieve your objective. A lot of people just want to focus on try to, find something in the environment, and they're happy with that without even caring or understanding exactly how they can be more efficient at doing that. So when I go to several organizations, there are different ways that you can do threat hunting, and I can just summarize this in a few steps, right? All the way from generating a hypothesis, trying to define your specific goal, what it is that you want to hunt for, all the way to, trying to document the results and also try to enrich your security controls that you have. So if we go a little bit into these steps, I see a lot of organizations using their own intelligence, internal or external, in order to understand what it is that, that they can hunt for. I don't see too many people using the data that they have, right? They don't understand exactly what they have, so they do not use it to define what it is that they can see in their environment. I see only a few people doing that. And then some organizations focus more on the critical infrastructure, and it's a mix of using intelligence with entity-driven, and that's how they do their hunting engagements every quarter or, through the whole year. And of course, I've seen a lot of companies using business goal-driven, and in this part right here, it's very interesting because you have a lot of organizations just trying to follow regulations, right? I don't care if this is not a critical infrastructure. I just need to check a box. And this happens, of course, across several industries, and of course applies also to to threat hunting. And it's not the right way to do it. Some of the problems that I see a lot, and this is why we decided to build this presentation, was to define what it is that I need for my hunting engagement. And the question keeps getting repeated over and over. Every time I go to a company, they always ask the same question. And it's because they don't understand, first, how they're going to be using their current infrastructure and their current data to start hunting for any type of activity. And of course, some organizations like to be more organized, right? they have roles and responsibilities, and others have just ad hoc queries where they just, give the analyst a search bar and they just start running queries whenever they have time. And this, of course, defeats the purpose of the whole, framework. And of course, they document it and they, of course, try to, enrich the security controls. And once again, the reality is is in here that even though everybody wants to get this nice threat hunting framework, at the end of the day, you just give the analyst a platform with a search bar where you can just run anything that you want to. And most of the time is defined by the expertise, right? Level of expertise, and also what you might see out there in the internet, right? And your queries might not be as efficient. So there needs to be a methodology to understand how you can be efficient and also at the end being effective at hunting engagements. And of course, I hope that this presentation at the end would allow you to understand that when you do a hunting engagement, everybody just wants to spend their whole time running queries, trying to find for any potential adversaries. But reality at the end is that there is a lot of pre-hunt activities that need to happen before you even try to deploy a hunt or start a hunting engagement in your environment. And it's going to be more, it's going to make some more sense once we go through the whole methodology. So a data-driven approach, and why do we even care about this, right? So let's just go back to the basics. An adversary is building their own tactics, techniques, and procedures, and they're trying to, bypass detections. Every time they do a simple action on the endpoint, it's going to generate data. That data it's going to be fed to a central repository, and then you can start analyzing that data. Security analyst starts learning about those TTPs, and then you're going to start running queries and things like that. This is just the basic concept. The problem is that organizations are really not understanding if they're getting the best out of this data. They just collect the data, they put it in a central place, and they don't even understand exactly what it is that they can do with that. They are more interested on creating rules, signature, kind of like brute forcing detection, trying to find specific strings, specific things that they see online, like people talk about it in conferences and things like that. But they probably are not using other ways to analyze the data, right? Which could go all the way to the statistical model, trying to find more information and more insights from the data. And this is what this presentation is going to be about as well. So at the end, we want to understand the potential of our data as a whole. So this is going to be our, basic steps to start going through the whole methodology. And for you guys, this might be a little high level, and some of you might see this as basic, but we're going to go actually deeper into each stage and will allow us to see what it is that you can do, to improve your detection. So the first thing is going to be defining a research goal. And as I explained before, you can do it in so many different ways, defined by intel or defined by data. But when you want to focus on data, you have to at least ask yourself the question, do I understand my data? Do I have it documented somewhere? You need to have that somewhere in your environment. Otherwise, you will not be able to start asking questions about your data and what it is that you can hunt. And of course, in here is where you have to start mapping certain data logs or events to adversary activity. This might not make sense for you right now, but it's going to make sense in a little bit once we go through the stages. But the idea of building your hypothesis is to start grabbing that knowledge about adversary technique and start putting that together in a data concept. And of course, you got to document your hypothesis and respect it through the whole methodology. And this is going to apply to our effectiveness, efficiency, and efficacy concepts, because now with our hypothesis, we are defining how the efficacy, the specific goal, what it is that we want to hunt for, and respect that at the end. And of course, from an efficiency perspective, now we have to start defining what resources and relevant data we're going to be using for this detection. The questions that I have a lot are, how specific do I have to be in order to build my hypothesis, my goal, right? Do I go very specific or very wide? I think that question can be also answered with the next question, which is, how many techniques from an adversary do I have to cover in my hunting engagement? In this case, for example, you can be very specific. Let's look for adversaries that are enumerating, for example, the Active Directory group domain admins, and they're using, for example, security account manager, remote protocol. That's very specific, right? There are different ways that you can enumerate an AD group, right? These Active Directory group members. You can do it through SAM, in this case, security account manager, Or you can do it probably through other services. You can use, for example, LDAP to query directly the Active Directory object and get that information. So that's how you start defining how many techniques you can start applying to your hypothesis. And please remember that when you execute something in your environment, like an adversary executes something in the environment, they need some type of techniques that allows them to enable that execution. What does that mean? If I'm trying to, to enumerate the members of an Active Directory group, something needs to happen on the endpoint to allow the attacker to make that enumeration. This could be done through PowerShell, could be done through .NET, right? Through Python. You can do it through any other different ways, but the main goal is the same. So you have to consider that when you start thinking about your hypothesis. Am I focusing on the enabler, or I'm focusing more on the main behavior? And of course, at the end, the outputs of this first step, which is more documentation and research and learning about the attack, it's going to be a full documented hypothesis. It's going to be knowledge about the adversary, and you're going to see why this is important in the next couple steps. And of course, you got to provide some relevant data. If your hypothesis is about an adversary creating a service remotely, right away, without even looking at the data, you know that there is going to be some service creation auditing that you will need to take a look at, right? So that's when I say relevant data. The initial relevant data of your research could be defined by the data that you have. But if you don't know what you have, there's going to be a problem, right? So, in this step, you have to start at least understanding that there is some type of data that will be mapped to certain behaviors in your research goal. So let's think about this hypothesis right here. Lateral movement via WMI, and I'm going to start sharing some of the knowledge, things that I'm learning about this specific technique and tactic and technique. In this case, I want to be very specific. I want to start looking for lateral movement via WMI that is going to create a new process on the destination, which would allow me to create, to get a new connection back to my command and control. This could be done through, of course, the WMI class win32_process. And you can use the method create, which is the method that allows you to execute things locally and also remotely. When this happens on the destination, on the endpoint where I'm executing my code to then generate a new connection to my command and control, that execution is going to be hosted by the WMI PRVSC process. So without even running any code or collecting any data, I'm already understanding a little bit what it is that I need. I'm going to be looking for some network activity, for example, some authentication going on. I'm looking for a process creating another process, and that same process making a network connection. Like, I'm just learning about this adversary activity and trying to map it to data. The next step is going to be now start modeling this data. Let's just start understanding how we can find relationships and start mapping my data to an adversary in a more direct way and more easy to follow. So in this case is where we start now getting more deeper into what it is, that you can use from what you're collecting in your environment in order to spot the adversary behavior. If you have not done any type of documentation in your environment about data sources that you collect, here's the step where you will have to do it no matter what. Because if you don't do it, you'll just keep pushing yourself more and more towards the next steps where you're going to need some knowledge about your data. So let's just start first with data sources, right? What does that mean when I talk about data sources in here? From a basic concept, data sources are coming from, let's say, like this EVTX file, which contains events that are generated on the environment. This is what everybody knows, right? Everybody understands this concept. This is just basic. These EVTX files, when you can pull them out of the endpoint, you can do some forensics, you can learn about what happened in the environment. But this is generated by what is called the event tracing for Windows ETW providers. This data gets generated. In this case, the security event log is generated by this ETW provider. And this is done also the way how you send data from an ETW provider to a specific log file, like a, security event log, is done via the event tracing sessions. And this is the basics of ETW infrastructure. Why I'm talking about ETW? Because it's very important to understand where the data that is available is coming from, because you will be able to also understand that there are certain ETW providers that would allow you to get some unknown data and not practical available for you to consume. Why is this so important? It's because nowadays adversaries are moving from using things like PowerShell, for example, because there is already full auditing on PowerShell activity. So now they're starting to use, for example, .NET in order to bypass those detections. Now, there is certain ETW providers that will provide that information about .NET activity. So just basic concepts. But this is not easy to consume. You cannot just, get a file from this ETW provider and consume it. Some people call this concept of using unknown data sources or not practicable ETW providers a very advanced and mature way to collect data. To me, it depends on the goal. What is the goal? Is the goal in our detection methodology to look for .NET activity? Or the main goal is to start focusing on the behavior of the attacker, right? The behavior on my basic hypothesis was to look for WMI, using WMI for lateral movement. Do I care 100% or make the primary goal to detect .NET or lateral movement over WMI? So you gotta ask those questions, and that's how you define exactly how advanced or mature you wanna be when collecting your data. And of course, you need to know what you have in order to know your gaps. Otherwise, you cannot say, I need to use unknown data sources or not available ETW providers if you don't know that you might be getting similar data already from available known data sources. In this case, I'm going to show you a quick demo into what that actually means. How can we collect ETW, data from ETW providers that are not practical available directly for you to consume at scale? An example that we're going to be using is DCSync. And DCSync, basically what happens in here is that the adversary, well, first, like in general, the basic concept of, replication happens, across domain controllers. You have a domain controller, that could be here in Geneva. You have a domain controller that could be in the United States. They both need to have the same data. So if something happens on the Geneva domain controller, we add a user, we create new configurations, that needs to be replicated somewhere, right, to the other domain controller. So that type of activity is normal. Nothing is broken in here. So, but an adversary can abuse the Active Directory replication APIs in order to request for those changes. You can say, hey, I'm a domain controller and I would like to get the password of this user. Please send it to me because I want that replication to happen towards me. So adversary can be using that. And the permissions that you see over there are the permissions that are going to be used in order to execute this attack. So let's do this quick demo. In this case, we're going to be using DCSync. The compromised user is Pedro. We're going to try to get information about the KRBTGT account. And we're going to use the invoke Mimikatz script in order to perform the DCSync attack. We're going to perform the attack, but at the same time, we're going to start using an ETW provider, which is the RPC provider. I'm going to explain to you why I use this one. But in this case, we have our computer that was already compromised. This is going to be our domain controller. So we're just going to make sure we check the name in there. And let's just explore ETW a little bit, right? Because when you say, how do I explore my unknown data sources? Let's do some ETW stuff basic. Let's just start enumerating the tracing sessions that are available in your computer. Remember, a tracing session is what makes events go from an ETW provider all the way to a log file. So you can start at least querying these tracings, and you can understand exactly what's being pushed to log files and things like that. But let's pull all the ETW providers available in the computer. Let's save that to a variable. And then after that, we're going to start looking for ETW providers that do have the word RPC. The reason why I look for this is because if I did the research about DCSync, Active Directory Replication Services, when a domain controller communicates with another domain controller, are pretty much using RPC interfaces. So I would love to know if there is any RPC activity that I could actually track with an RPC ETW provider, right? That's my goal. That's what I look for that. So let's pick the first one, right? This actually, I was doing some testing with this new tool that came out yesterday. And that was awesome because I was able to update my slides and show it to you. So this is a tool called Silk ETW. You can find it in GitHub. And it's actually created by Ruben. and his handle is fuzzysec. But just look for Silk ETW from FireEye company, and they have that already in GitHub. It's open source. So in this case, I'm using this tool, and I'm pointing that to a specific ETW provider. In this case, it's going to be the RPC one, and I'm telling it to please write all the data to a file. You already can see how this is not as practical to scale, but at least from a research perspective, allows me to see what else I can get. In this case, we got that running, and you can see that there's going to be events actually being, captured, even though I'm not executing this async, and that's because RPC is not only used by this attack, right? RPC is used in general by, just other things happening in the computer. So if I execute this attack, so you can see the events are just keep going up. And so I'm successfully capable now to get the NTLM hash of the specific account that I wanted. So my attack, it worked. And I can just stop my ETW provider. And then after that, I can start probably reading these contents of this file. But this is not, of course, as efficient to be going through this and doing Control Fs and things like that. So what I do is I just push that into my own elk stack, which is just a platform that allows me to, centralize my data and start running some queries through Kibana. And Kibana uses, Lucene syntax. So it's that's limited, but at least it gives you a good platform to export your data. This is easy to import, and at the end I'll show you how you can do some of that with our new project. I imported that to my elk stack. I have that in an index. I have all this data in there, and then I can just go through all this information. But first, I gotta go back to my knowledge base that I was trying to acquire when I built my hypothesis. Let's read about replication services remote protocol. There is some operations that need to happen, right? From DC to DC, from domain controller to domain controller. So I need to learn about that. Once again, I don't know much of this, right? And as you too, if you go to your company, you want to look for a specific adversary technique, you will not know right away 100% what it is doing. So you have to do some reading. Microsoft have a lot of good documentation. As you can see in there, in order to connect to a domain controller, it's going to use a directory replication service RPC interface with a specific GUID. And that GUID is pretty much a sign of, communication via directory replication services with the domain controller. So what I do is I just look at my ETW provider events and I start trying to figure out where can I find that information. And of course, there is already an interface field in my data, as you can see in there, and I have a specific GUID in there. So I can stack those values, see what I have based on my ETW provider, but of course I can jump directly straight to the one that I was looking for that I know it's part of my, RPC communication with the domain controller for directory replication services. This is very interesting because until today, online, if you go to Twitter or, anything like that, when you talk about detection of DC sync, they focus a lot on the network layer, on trying to, pull a PCAP and trying to understand the specific communication happening. And most of the data that you collect for DC sync happens on the destination, on the domain controller. The domain controller tells you, hey, someone is asking for permissions to something and is using replication permission. So take a look at it, right? You always get that from a domain controller. That's consumable data that you can get right away. But this is important to know that you can also get information from the client. And in this case, you can get it through RPC ETW providers. Tools like Microsoft, for example, is called Windows Defender Advanced Threat Protection. They use these ETW providers through their tools to give you that data. So now that you know that you can find this is synced from the client side and not just only the server side, you can probably utilize that in your tools. But if you don't do this research, you don't know where you can find this data. The same thing happens for other attacks like Power View, enumerating Active Directory group members, for example, using LDAP. There is not information directly available about LDAP locally to tell you that there is a filter or a search going on that is going to look for domain admins. If you look for this ETW provider, which is the Microsoft Windows LDAP client, you can start listening to this, going through the same process that I did, and you can pretty much find a specific LDAP queries at the client level where you can see how they start looking for domain admins and things like that. This is very interesting. So you're going to start defining based on your research, you have a goal, you have available data sources, but you also have, unknown data sources that might be useful, and you might probably have to do some more research to know how you can consume that at scale, right? So when we start thinking about data modeling, now that we understand where our data comes from, which as you know is very interesting to know where your data comes from, so you can start now doing some documentation. You might be asking yourself before, how do I do documentation? You were telling me to do it, but what does that look like? So data documentation, of course, you're going to have different data sources in your environment, but each data source in your environment needs to mean something, needs to be mapped to an event. In this case, process monitoring can be mapped to 4688 from Windows security event logs. It could be process termination as well, because we're not just focusing on creation of processes. It could come from other data sources like Sysmon. Process accessing. At the end of the day, you have to understand each event of the relevant data sources that you're defining. You have to understand that data, in this case, creating data dictionaries. This might be a little tedious work. You have to do a lot of reading, going one by one and do it. Believe me, a lot of people that I talk to about this in companies, they rather pay or they rather just not do it at all because they feel it is a lot of work. But this type of documentation happens most of the time once, and then you pretty much just maintain your data wiki. Believe me, this might be simple, but this is very useful, and a lot of companies do not even have this level of documentation. So at the end, there is a project called Awesome that my brother and I put together, which at least gives you some data dictionaries and allows you to see how you can categorize your data and document it and all that. The link is at the bottom. We're going to release the slides also later, so you can just take a look at them later. That's going to take us to the next step of our data modeling whole concept, which is going to be standardizing our data. Why do we care about this, right? Some people fall asleep when I talk about these type of things. And that's because nobody wants to, right? Everybody wants to do the cool stuff with ETW providers and finding unknown data. Everybody wants to do that, right? But you have to do this as well. You have to understand how you can create a standard schema for several of the data sources that you're collecting. Otherwise, it's going to be hard to query your data at scale across several data sources. In this case, how do we do this? Each event log is going to have what we call an entity. What means is that if you have an event log that gives you information about a user, that user field should be part of a whole global schema. If you have information about a process, that needs to have a global schema as well. So next time you get a data source that gives you process or gives you user information, you already know how to name that field. Okay? So if we go to the user entity, we have a lot of different definitions and field names for user, right? And this might change in your environment, but at least it's important to know what it is. Let's pick the first two, and I'm going to show you why it is important. Username to me, as a field name in an event log, should be the user that is performing the main action in the event. In the user reporter name, as its name says it, is just a user that reports that event happened. If we get two events, 4624 from security and 4648 from security, we do have two field names that are the same name, but they mean two different things. So if I do not parse my data or standardize it or have a schema, your security analyst will treat these two field names the same as if they were the same, but they're not. In 4624, the subject username is the user that reports activity. And in 4648 is the user that actually performs the action and requests a new login session with explicit credentials. So that's a pretty big deal. Like, you have to know exactly what you're querying. Otherwise, you're going to have a lot of values in your queries, or when you stack your values, that will not make sense in the context. Once we do that, then now we can start thinking about data modeling. And data modeling as a whole is just basic defining structure of your data and also relationships that you can find in them. There's a company called MITRE. That's a nonprofit in the United States. It is the MITRE Corporation, and they build their own data models, and they are inspired by Cybox and STIX syntax, which is used for threat intelligence. But let's just go straight to what it is, right? This is used for cyber threat intelligence, where you're going to start building this like basic knowledge graphs where you can say an adversary can be mapped to a piece of malware and, things like that. And you're going to start adding some properties to these specific nodes on your graph, on your knowledge graph. This can be applied also to Windows security event logs or any other event log in general. Because you have also files, processes, IPs. Remember the concept of entities in a data model, and you use those concepts as well. And there must be some relationships across this, because by nature, a file does not get created by itself. A file gets created by something. In this case, our data tells us that it's created by a process. A process, when it connects to an external location, technically the process is connecting to an external IP. And if you start adding properties and attributes to this based on your data dictionaries, you're going to start identifying that there could be some relationships across this specific, event logs and things like that. So this is basic, but this specific model would allow you to start building things like this. This is the Sysmon Windows Sysmon data model, which tells you all the different relationships that you can find in Sysmon event logs. So the process creating a process relationship is provided by the event ID 1. Process creating a file is created by event ID 11, and so on. So you can create this nice graph that at the end would allow you to start mapping activity of an adversary to a specific data source or event log. So let's think about this. There is a technique on the right of you. That's the ID. And then you have a couple data sources, but you have to make sense of process monitoring. Now with your knowledge of data modeling a little bit in data dictionaries, you can right away say, process monitoring, I have information from creation all the way to access. Each specific, sub data source in there or the relationship created, that should be mapped to specific events. Because the moment I ask myself or I ask you, hey, do we have anything that tells you when a process accesses another process? You should answer that question and say yes. That comes from Sysmon event ID 10. That relationship that you're looking for, it's mapped to my specific event 10. And that's how you start defining also relevant data that you can use for a hunting engagement. So you are taking the whole expertise a little bit away from this whole methodology. Why is that? I work with people that tell me I don't need this because I know what I'm looking for and I'm an expert. And to me, it's like no one is an expert. There's always a lot of things that you need to learn. And in this case, obviously, there's a couple things that you need to learn from how you can map your data to specific techniques, right? This would allow you to start mapping in a more factual way an event ID all the way to a potential technique from an adversary. And I expect that to be, of course, documented in this type of format. For example, if you go to that link over there, once again, it's going to be shared later, and it's part of the Awesome project. I already have a couple of data relationships mapped to event IDs all the way to the specific configurations that you need to enable in your environment to also collect that data. So some of the work's already been done out there, so probably you can use that to start and then build it with your own data sources. So what does that mean, data modeling with the adversary behavior, right? Some of you might be saying, that doesn't make sense still. This guy is not explaining it properly, right? So let's go back to our WMI activity. We know that the main goal is to move laterally. We know that this could be accomplished by the Windows Management Instrumentation framework. And if I want more detail, this can be done by Win32 process class with the method create. And of course, the specific procedure that we're looking for is a new agent, a new connection talking back to a command and control. Meanwhile, the adversary has their own tools, their own infrastructure, and they see some of these probably like with some cool graphs trying to, waiting for that beacon to call back. I look at it from this perspective. Without even running the attack, without even collecting data, just by documenting and modeling my data, I can start understanding, based on my knowledge, a process is going to connect to a host. That's going to create a potential authentication. So I'm expecting a 4624. There's going to be some process talking to an external IP. That's going to be an event ID 3 because I know a process to an IP is an event ID 3 from Sysmon. We know the WMIP or VSE is basically the process that will be executing whatever you wanted to execute on the destination. Well, if I have event ID 1, I can have my WMIP or VSE as my parent, and then my child, I don't care about the child, but the child is going to then make a connection to the network. So you can see how important it is to understand your data so you can map potential behaviors to your data right without even starting to analyze the data. Based on your data modeling, you can then say, well, 1 and 3 are actually related to each other by a specific field called the process GUID. That's provided by Sysmon. So Sysmon gives you already that relationship. So if you did your due diligences and you wrote your dictionary about 1 and 3, you will understand why process GUID is the unique value that would allow you to link two event IDs. This is how you model data, and also you model that data to an adversary behavior. So in this step, now we're going to start simulating the data. And we're not going to spend too much time on this because I believe this is just makes sense. You're going to simulate an attack. You need a research environment. This is part of the project that we're going to be releasing today. So you're going to get more information about that. And you need to have a plan. One of the best plans out there that I've seen public and open source is the MITRE ATT&CK's team APT3 emulation plan. Once again, if you want to, simulate one technique or two techniques or a whole campaign, up to you, depends on your goal, you might want to do something like this. At the end, when you start executing your attack, there's going to be events that are going to be generated. Remember, at the beginning, you define relevant data sources that you need. And when I show you the data, this specific picture from a data modeling perspective, you at least have an idea what you will be expecting. But when you are working on a lab environment, I would highly recommend to get more context so you can be a little bit more creative. If your relevant data sources does not tell you much, you can use other data sources available for context when the attack gets executed. But make sure you document those specific events. So some basic concepts in there. At the end of the day, we're going to start defining a detection model, right? We're going to start now going into how are we going to hunt for this, right? We can use our initial data modeling. We were able to validate the relevant data sources that I needed when I, simulated the attack. I can come up with this query, like a SQLite type of query. I'm collecting information from two events. And the reason how I can do this is because I can actually use the process GUID to join these two events. And I can filter this data by WMI PRVSE because remember, my knowledge was telling me that whatever happens on the destination is hosted by WMI PRVSE. The attacker cannot control that directly. That's just how the computer behaves. The attacker can control the child. The attacker can control what is executed by WMI PRVSE, but the attacker cannot change directly WMI PRVSE process on the destination because that's just the way how WMI works. Having that knowledge, I can easily put that WMI PRVSE string in there. The idea is to be able to collect this data and then test it in my lab environment. And of course, it's a lab environment, so I expect that to be true if I'm trying to detect for that specific activity. In this case, we do have a process mapped to an IP to a process command line. And the command line, of course, is just a basic payload being used in order to communicate with the command and control and start the whole, handshake to start the connection. So the process command line is not actually available on Sysmon Event ID 3. It's available in 1 because 1 is process creation and gives you information about the process command line. But since I'm joining these two log files, I can get that information together and run a query on the top of that join. If you do not find anything, right, this process is not a one-way. You will have to probably go back to your research goal and adjust it a little bit. Probably you're being too white. There's a lot of false positives in here. Probably get a little bit more detail, right? Check your data model. Check if you're missing anything from a relevant data information. And probably simulate it again. You probably miss a couple of configurations. So this is a kind of like repetitive process that you will have to do if you get a lot of events after you run your analytic. So now it's time to start validating this in production because in your lab environment, it's not going to be the same as in production, right? It's just common sense. When you do that, before you do that, this is why this methodology is a data-driven methodology. You need to think about your data quality. Don't go and hunt or run queries in your environment without caring about the data quality of the quality of your data. What does that mean? According to the DoD, Department of Defense of the United States, there is a couple of different quality dimensions that you should consider when looking at your data. All the way from the data to being accurate, all the way probably to the data to be unique. This might apply to certain data sources, but for cybersecurity, at least focus on these three. Data completeness would allow you to know when your data that you're collecting is first configured properly to give you whatever you want to collect, complete, and also that you are collecting the data across the scope of your hunting engagement. If you say I'm collecting Sysmon and you have 100,000 endpoints and you're only collecting it from five, you're not being pretty much effective at what you're doing, right? So that's what completeness is about as well. And then data consistency is how you're going to be checking constantly that your standardization that you did before is constantly, let's say, up to date or of quality. And data timeliness is, let's do a hunt for 30 days and you only have data for 5 days. And the data is not of quality. You cannot validate something that has happened in the past 30 days. So that's the basics, how you're going to start assessing the quality of your data and understand if you're ready or not to start testing things in production.
So after we finish our data quality assessment, we are ready to prove if our data analytic works in production environment. So what are the possible results after this validation process? We can get 0 hits or at least 1 hit. If we get 0 hits, this means that the specific adversary behavior that we validate in our lab environment is not happening in your production environment. So, because we validate that our data analytic can identify the adversary in our environment, we can define this data analytic as a high fidelity analytic. Now, on the other hand, if we just get a few hits, right, it is really easy to us to investigate each event log. Let's say, for example, you run your data analytic and you get maybe 3, 5, or 10 event logs. Okay, so this quantity of event logs is really small, so we can just take the time and investigate each event log to understand what is happening, which are false positive and which are maybe indicators of that your environment is compromised. At the end, and the last option is what happens if after we apply our data analytic and we get a lot of hits. Okay, so an additional data exploration process might be recommended.
That happens a lot, actually. Every time I go to an environment and we just come up with these, nice analytic and, something that we can use, the day is a lot of different hits that happen because an environment, some of the activity might be just your normal activity, as, anybody of you probably have experience. So most of the time happens, which is the last one, where you need some additional exploration of your data.
So what does additional data exploration mean? Roberto already told us that we can understand our data creating data dictionaries, and we are going to understand our event logs from a description perspective, okay? But if we are getting a lot of event logs after we apply our data analytic, we have different options. We can go back to our initial steps and review if there is something that we can improve to improve, of course, our data analytic, or maybe we can use a different approach to get more context from our data. So let's try a statistical method to get more context from our data. And to do this, what we need to, the main question here that we need to answer is what type of data we have in our environment. So we are going to use 2 basic concepts to describe our data. The first one is related to the structure or the organization of our data values, and the other one is the numerical description that you can use to with your values. Now, this process is not only going to help us to understand what statistical methods or concepts you can apply with your data. You can also learn more from your data because you're using a different perspective. Mm-hmm. So how can we identify if we have a structured or unstructured data? It's really easy. If you have values in your environment that are following a specific rule, right, to create every value, for example, the computer name field is a good example of organized data because in this case we are using the first two characters to identify a specific department of an organization, and we are using the other three characters to identify maybe the number of computers we have on each department. And a good example of unorganized data is the process command line field, because every value you can get on that specific field is not following any rule or any standard organization hierarchy. So for example, what methods can we use with unorganized data? If we have a value from this is an example of a process command line value, so we can start calculating the length of the value. So that means how many characters we have in this command line value. Or maybe, for example, we can just create new information just looking for specific characters. Do we have any specific character in this value of command line? And an additional method that we can use is just add extra context. So it's like you can tag this event, this value. For example, this value is using WMI processes in your computer. So you're just adding extra information about this. So we got a lot of event logs after we apply our data analytic. Now, if we see all these values, we can start sorting our values. Okay, so let's focus only, my hypothesis is related to WMI processes. Okay, we can start categorizing our data. Mm-hmm. Now, what about organized data? So to start that analysis, we need to understand a basic concept first. What is quantitative data and what is qualitative data? There is really basic. Quantitative data is data that you can represent with numbers, and qualitative data is data that you can not only use numbers, you can also use characters or symbols to represent the values. So what methods can we use with qualitative data? For example, in this example, if we use the username, we can start adding more context to identify which of these users are related to user accounts or computer accounts. And we can also start using or perform a stack counting procedure. So maybe if you see your hypothesis, you're looking for the most frequent or less frequent values. And there are also another methods that you can use, like again the length, or maybe you're interested on specific unique values, or maybe you can, or maybe you're interested in the frequency of this username over time. Mm-hmm. Then something interesting about qualitative data is that if you see all these values that we have for the field username, we know that they are different. We know that they are allowing us to identify each value, but we cannot make any other analysis. We just know that they are different. So we can add more information about the username. For example, if we use a privilege tag, we can start identifying which username has privilege as a domain admin or maybe as a domain controller. But what is the difference between this data and the other one? Is that now we can rank our data and we can compare it. Okay, so our hypothesis is related to users that
have high privilege. Right?
Yeah, that have high privilege as a domain controller or maybe as a regular user. Mm-hmm. Now, what about quantitative data? We need to understand that there are two types of quantitative data. So there are discrete values and continuous value. So discrete values is you use numbers that you can count on a specific range of data. Let's say between 1 and 10, you have only 10 options. But when you have data that, let's say, for example, between 1 and 10, but you are considering maybe decimals, right? You will have infinite possibilities to use for each value of your data. So what kind of methods can we use with quantitative discrete values? We can also, again, we can perform a stack counting procedure and also understand the frequency. And because we are using numbers in quantitative data, we can also calculate descriptive statistics, such as the average or the minimum, the maximum value, or the mode. But in this case, if we see our data is related to IP ports, if we find the average of several IP ports numbers, this data doesn't make sense, right? But if we see another example for the values of bytes in or out from our network data, these values, this descriptive statistic now are going to make sense for us. For example, what is the mean? What is the standard deviation of the values? Which is the maximum or the minimum? So the idea of the standard deviation here, for example, is the standard deviation gives you an idea how similar are your values or how distant are your values. So if we graph these values using a box plot graph, we can identify, if you see on the left, most of the data is on the left side. That means that the number of bytes that are transferred are between 3 bytes all the way to maybe 125 bytes. Mm-hmm. But you have values of bytes that are transferred that are really big, that are on the right. So using this box plot graph, we can consider these values as an outliers. And maybe we can start from all the data we got after applying our data analytic, we can maybe start focusing on this one.
Yes, so that was very interesting because, for example, when I was doing a couple of different engagements, most of the queries or analytics that you come up with are usually a rule where you focus on if this string with this string does this, then it's malicious or potentially malicious, right? And that could be translated all the way to a basic signature. This concept right here allows you to think about your detection now with kind of like improving the way how you look at data. I've seen actually analysts calculating the median or the average, right, of a port. All right. Can you connect to a port, 0.5? Right. You cannot do that. So that's why it's important to understand that you cannot do certain things to specific data types. And this is so important because this allows the methodology not just to focus on basic rules, but then probably start getting this statistical way, which is the basics also to start getting into potential machine learning models. Not every technique detection will need a machine learning model or a statistical analysis, but this is a way where you can now take the other route if you cannot, of course, detect it with your own basic rules. So the next step is going to be, of course, documenting. And the way how we like to document is through 300 playbooks. And there is a project actually that we both also host, which allows you to put together a couple of fields, and you have to pretty much document everything that you did with these fields. We can go all the way to the title of the playbook, all the way to the potential data model, the relevant data sources, what you did from a data analytics perspective. Do you need a rule? Do you need any statistical model? What is it that you need through your whole detection capability? Now, this can be, of course, translated into a nice, either markdown or whatever you want to do. And I'm going to show you how this could, of course, be put together in a little bit. So at the end, we talked about our whole methodology, right? And as you can see, even though it looked a little high level at the beginning, there is a lot of steps that you have to do in the middle, which would allow you to be ready to then be sure and say, we created this data analytic. We look at the data quality before we even went into production. So we are sure that if we do not find anything in production, I'm sure that I pretty much was collecting the right data. So I can be a little bit more sure that the attacker did not happen. Or the adversary pretty much was using a different variant that bypassed my hypothesis. But that's why I have other hypotheses that I can create. When I say that you can do it yourself is because there is a lot of projects that we host. It's open source, right? And as you can see, we love animals, right? And, we love our logos. And we have the OSEM project. The OSEM project is going to focus a lot in providing information, data dictionaries, things that you can do, with your data, document it, data modeling, specific documentation, also standardization, showing you a basic common information model. All that is in Awesome. So if you want to learn about that without doing the heavy work, I've already parsed, I think, at least almost 200 event IDs. So probably you can at least learn from that and probably apply it to your own company. And it's very important to have a data wiki. I have no idea how, easy it is and useful, for engagement. We use Helk, which is our, the analytic platform that allows us to, of course, go to the data and start analyzing it. But Helk, what it has, it also goes beyond the search bar concept. It gives you Jupyter notebooks, which allows you to do a more scientific analysis of your data. And of course, Jupyter notebooks are used by data scientists to perform their daily jobs. And the 300 playbook is another project, which is the logo. You guys are actually the first people that are seeing this new logo. It's actually my dog that passed away, unfortunately. But so in memory, that's the 300 playbook logo. So the project that we're going to show today is Mordor. And the reason why is because we're still missing a step over there. We're missing the step that a lot of people say, I don't know how to, replicate the attack. I don't have the skills to start running my own command and controls and things like that. We have Mordor, which is, of course, a tool that allows you to replay adversary behavior. And is, of course, from the awesome films and books of the Lord of the Rings. I love that. So I figure it'll be good to have a Mordor gate because we're pretty much collecting malicious activities. So Mordor is where, the Sauron forces live. So it makes sense, right? So the reason why I say this is because if you use one specific atomic red team toolkit out there, which exists, that are open source, and you execute this async, at the domain control level, you're going to get that log. If you execute several different, red team toolkits, you're going to get the same log. If you execute it through PowerShell, you're going to get the same log. If you execute it through .NET, Python, you're going to get the same log. Right? On the domain controller, the main behavior that I'm looking for is going to be the same log. I can use other frameworks or probably, Mimikatz to execute this async. It's going to generate the same log. Right? So, let's just pick one of the ways to generate that data. Let's push it to Mordor. And that's the logo, by the way, which is it's just a work in progress. So please don't judge me by the logo. It's just a work in progress. Actually, the lady sent it to me 2 days ago and I was like, all right, this is what I can work with. So that's fine. Anyways, but this, Mordor will pretty much store that data and give it to you directly. There is no need to be doing all this stuff on the left. You can just have it directly to you. Right? So that's Mordor, allows you to then query data and not just one event. I'm not just giving you 4662. I'm giving you a whole time window of events with several events that go around this async, for example, context. And you might ask yourself, how do I consume that, right? How do I get that data from Mordor and send it to my Elk stack or to my analytic platform? Well, I give you Kafka Cat, command lines. Kafka Cat is a tool that allows you to push data as a producer to a Kafka infrastructure. Kafka is a publish and subscribe infrastructure, right? You can publish data to Kafka, and then you can subscribe to the Kafka and then pull that data out with any other tool. LSAT, Jupyter Notebooks, KSQL, and things like that. So Kafka Cat allows you to then pick one of the Mordor files and then replicate it back, send it to Kafka Broker, so you avoid the whole execution and simulation, and you pretty much can have it as if it was being loaded in your environment. So you can see I'm loading a whole series of events as if pretty much happened. So I'm simulating the specific attack, but from a data perspective. I'm not worried about all these other techniques. Once again, I care more about the main behavior. If you do it with PowerShell, with .NET or Python, good for you, right? And that would be awesome to have different versions of the Mordor file. And that's the next step. I'm going to have a file from PowerShell Empire, a file from Covenant, which uses .NET. And so that way you can see that the main goal, the end goal of my detection will still be the same, but then you can have also context around different tools that allow you to execute that attack. And of course, now at the end, you can do it yourself, right? Because now you have all the tools. This is going to be released tonight. So keep an eye on that GitHub link over there. So real quick, I'm just going to show you Mordor in action because we have 2 minutes. So this is Mordor, so you can just go and download it. You have the goals and everything from Mordor. Each file, as you can see here, this is a disasync file. If you can click on the disasync, come on, click, Roberto. Man, this guy's taking forever. All right, so we click on that file, and then we get information about disasync. We're getting information about who created it, the data set, the specific network environment, when it happened, because if you ingest this data, it's going to have a specific time window of timestamps. So you have to know where it was taken so you can at least, adjust your time query. And then from there, I give you the specific events, IDs, specific data categories and data sources and how many records you get per file. So this is very interesting because now I'm giving you some basic information so you can work with all these files and you might be able to come up with a new way to query the data. Once again, I'm giving you, let's say this is sync 4662, but if there is any other context that I'm missing, you have the data to do your own analysis and probably do some statistical analysis as well. So as you can see, I show you exactly how I executed it, so that way you know how I was able to do it, so you can learn as well if you want to do it yourself. And of course, the results. There's going to be a read the docs document, which you'll be able to see exactly how the environment was created and, what it is, the endpoints and stuff like that. And I want to show you how to consume the data. You can go to the Kafka Cat style, and you can learn exactly how to do it. It's very easy. We're going to go straight to how to do it. I download the project Mordor. I already have my elk stack, which I already give you two commands to create this specific stack. And then I pick my file and I decompress it. And once I decompress it, then I can run this Kafka Cat query. B means the broker where I'm sending the data. T means the topic where the data is going to be stored. And P means that Kafka Cat is going to be a producer. It's going to send the data as if it was being ingested in real time. And of course, I point into the file. So at the end, I can just go to my small data sets, windows. All this data is categorized by platform, tactic, and technique. And then I can just, as you can see, there is nothing in there, but once I send the data with Kafka Cat, I can automatically start seeing these specific events over there in my elk stack. And if I run my query for this is sync, I can find this is sync in this data set by looking for a specific replication permission that gets created for 4662. So I just replicated the data right away straight to the elk stack. And thank you very much. So if you have any questions, I think we're out of time, right?
Yeah, if you have one or two questions, you are welcome, of course.
Oh. All right. If we're going to be around, just in case, if you guys have any questions, we're going to be around. If you want to talk about data, just let me know. If you want to talk about Mordor, let me know as well, because I would like to probably have some ideas, or you might have some ideas that I might not consider. So thank you very much. Appreciate it.
Thank you. Thank you.